Okay, the objective of this video is to determine if there's a relationship in the volume of prisms that have the same height. So we have some prisms here, and they all have the same height. This one is a triangular prism. The top and bottom are congruent triangles.
And the walls go straight up.
Right, walls go straight up, all the sides are straight up. Then this one is a square prism where the top and bottom of it is congruent squares. And this one is a pentagon, trying to be anyway, where the top and bottom are congruent pentagons. And this one is a hexagon, top and bottom, and the walls are all straight. And then this one is a cylinder where the top and bottom is a circle. So how can we figure out how they compare in volume?
That could be a lot of work, but I think maybe if we pour something inside of them, figure out how much each one holds, and write it down, we'll know which one holds the most.
Okay, good. I think we should start with the triangle because it has the least number of sides.
I do too.
So we have a bucket here. We put our triangle in there.
Tell you what, you hold it
Okay.
to make a triangle, and I'll put rice in. Okay, we're going to put 250 milliliters of rice in. So that's 250. I think we can keep track of these numbers in our head.
Okay.
So we've got 250 plus another 250.
That'll be 500.
500 milliliters. Think it'll take another 250?
I think so. Pretty close. So a little less then?
Yeah, let me see how much this is. We had, if we would have used it all, we would have used 750. But we've got 15 milliliters less. So that would be 750 take away 15.
Right, so that would be 735?
735.
Okay, so I'm going to write that down. Our triangular prism was 735 milliliters.
That's right. Okay.
So do we have to start completely over?
I think if we just use all this to fill the next one, we know it's 735 to start with.
Okay, that sounds good to me. I'm going to just dump that out.
Yep. And we'll dump that into this bowl, and that way we know how much we have to start with.
Okay, so here's my square.
And either we're going to have some left we're going to measure, or we'll add more to it.
Okay, so I'll hold the square and you
I'm
can...
just going to scoop these in. And it doesn't matter because we know this is
735.
735. Okay.
Okay, so this is 735 and there's still room.
Okay, should we add 100 at a time?
Sure.
Try?
Okay.
735 and another 100 if it takes it all. Ooh, pretty close. Okay, I'd say
So-
that's there.
So 835.
835 milliliters.
So it looks to me like the triangular prism holds less than the square prism.
Yep.
Or the square prism holds more. So can we say that? The square prism holds more than the triangular prism.
Right.
Okay,
All right.
we go on.
Yep. All right, we have 835 milliliters of rice in here, so we either will use more or less, and we'll measure what we do or don't use. So I'm going to dump this in.
Looks like
We
there's
need
still
more.
room, yeah.
All right, I'm going to go to,
I think 100's too much.
do you?
Mhm.
So we'll start with 50 more.
Yeah.
Okay, there's 50.
Maybe not.
Okay. So we're 50 extra so far. And if I, oops,
Okay, so 100 extra.
100 extra,
So that'd be 935.
935 milliliters. That's interesting. They're all so far going up by 100 milliliters.
That's interesting.
Okay, so now we said the square prism holds more than the triangular prism, while
The pentagon.
holds more
More
than
than
the
the-
square prism.
All right, so this is 935. Take that out.
Now, you know, after looking at what we've got on the board so far, my hypothesis would be that this one's gonna hold even more.
I would think so too. It seems like the more sides we end up having, the more rice it's holding.
Yep, well, let's see. Board. Well, let's say we're gonna need maybe 50 more.
Maybe 50 more.
Oh, not quite 50 more, I don't think. So we still have 15, so we added 85
85 more. So we need to add on 85. So that would be 10 carry. It's 12 carry. 1,020 milliliters.
Yeah. So we were right. A
It did take
hexagonal
more.
prism.
But it didn't go up by 100 this time.
No.
That's interesting, isn't it?
Mhm.
Okay, so
A hexagonal prism holds more than the pentagonal prism.
Yep.
Now a cylinder, that's got, you know,
How many sides does a cylinder have? Well, I just wonder, as you're looking at these, as you go from a triangular to a square to a pentagonal to a hexagonal, the closer I'm getting to a circle.
so maybe a circle has lots and lots too many to count.
Right, so I'm kind of thinking it's got infinite sides.
That's a good way of putting it.
So I'm wondering if, since it would have more than a hexagonal, seems to me, my guess would be it's gonna have more than 1,020.
And you know, maybe it has a whole lot more because we only added one side each time and now we're adding a whole bunch of sides.
That's true too.
But, let's see, this is 1,020 milliliters. I'm just gonna put this in. Well, I think we're kind of right in that it's gonna hold quite a bit more. I'm gonna add 100. See if it'll take 100 more. There's 100. Well, not quite 100. We've got 30 left, so it only took 70
more.
70 more.
So 1,020 plus 70 would be 1,090. So that means that the cylinder holds more than, and I say it hexagonal. How do you say it?
Hexagonal, whichever.
Either way,
Same
it's
thing.
acceptable.
Right.
That's right. Holds more than the hexagonal prism. So what conclusion can we draw from this?
Well, we said that the cylinder has an infinite number of sides. So the more sides the prism has, the greater the volume. But they all have to be the same height.
So if they have the same height.
Right. Because if they had different heights, it would could change a lot.
So do you think this has some bearing on, or there's something to this about the way that products are in the store? Because I don't see very many things in, hexagonal prisms. Do you?
No. It's either a square, a rectangle, or a cylinder.
Yeah. And if I'm just comparing the square prism to the cylinder holds more with the same height.
Right. So you could get more juice or more soda in a container that's a cylinder than you could in a square prism. So that's why soda comes in a can.